Hey everyone, we're going to look at number 9 in section 4.4 of Achieve. We're going to determine the intervals on which the function is concave up or down, and then find the points of intersection. For this function, we're going to use exact values for all responses. And there's several other details you want to read carefully in the problem, how you're going to enter your answers. You want to, if you're getting something errors because you're entering it in the incorrect format, you need to be careful and read those instructions. Here's the function. Notice they tell us that x has to be greater than 0. That should be automatic, even if it's not given, because the domain for the natural log function is only positive inputs, positive numbers. So the domain is greater than 0 automatically. And that's important. You don't want to give me an answer for intervals of concave up or down where you have, negative infinity or from -3 to something, right? There should be no negative values at all. So let's proceed. We're going to need the second derivative to determine concavity and points of inflection. So I take the derivative first for this function, and this is easy by the power rule. Bring the 2 down, I get 14x to the first power. And the derivative of natural log of x is 1 over x. Notice I wrote it as x to the -1 power, which is 1 divided by x. But I know I'm going to find my second derivative, so I like it in that form. Second derivative 14x is 14, and the derivative of x to the -1 being that bring the -1 down, x to subtract 1 from -1 to the -2, which I can rewrite as 14 minus 1 divided by x squared. So inflection points occur when there's a change in sign in the second derivative. And so we need to see where that would occur. And that's going to occur whenever the second derivative is 0 or undefined. It's potential to do that. But again, since our domain is everything greater than 0, the second derivative is never undefined. But the second derivative is equal to 0, all right, when this thing is equal to 0. Basically, that means 1 divided by x squared, right, has to be 14. Or 1 is equal to 14x squared if I multiply both sides by x squared, which means x squared is 1/14th, right? And then I can solve by taking the square root. Now, normally we take the square root, we're going to do what? Both the positive and negative square roots, right? However, we know again that x is greater than 0, so we're not going to take the negative root, only the positive root. Right? Square root of 1 is 1, square root of 14. I'm going to leave it like that. You could rationalize it, but I'm just going to leave it in that form. I'd like to do a sign check then, right, on the second derivative to confirm that this is a point of inflection, because just because the second derivative is 0 doesn't mean we have a point of inflection. We have to have a change in sign of the second derivative, which we do. So 1 over the square root of 14 is about 0.267. If I plug in something less than 0.267, but of course, obviously greater than 0, into the second derivative, I get a negative number. You can confirm that if you plug that into the second derivative. If I plug in something greater than 0.267, like 1, I can do that in my head. 14 minus 1 divided by 1 is 14 minus 1 is positive 13. So it's positive. So we now can answer all the questions. We're concave up where the second derivative is positive. So that's on the interval from 1 divided by the square root of 14 to infinity, right? That's everything up here. And then we're concave down where the second derivative is negative. Notice you have to start at 0, right? To this point, you can't go minus infinity here. Again, the domain is only values of x greater than 0. So you're restricted to that domain. So be very careful. You cannot put something other than 0 here. And then the point of inflection, they want both the x and y coordinate. So we have the x coordinate. I just plug into the function, and we get this, the square root of 1 over the square root of 14 is 1/14th. I get 7/14ths, which is a half, plus the natural log of this stuff. I think it's okay to leave it in this form. You could use property of logarithms to rewrite this as the natural log of 1 minus the natural log of the square root of 14, and the natural log of 1 is 0. So you could just write this with 1/2. This is also equal to 1/2 minus the natural log of the square root of 14. And we can maybe even simplify that, I don't know, a little bit differently, but I'm not too big concerned with that. You're still going to, they do want exact values, right? In other words, they don't want this value here, 0.267. That is not exact. They want exact values. So you have to write the exact value of x, and then I'm just going to write this expression in there for the y value. So this should work for your problem. Again, your problem is not exactly the same as this, as far as the numbers are probably a little bit different. Okay, hope this is helpful on this one. Let me know if you still have questions.